All right, so we're starting in chapter 3 here. We're talking about polynomial functions. Polynomial functions include linear functions, which we've already talked about, right? Y equals mx plus b. We've talked about quadratics, which are also a type of polynomial functions. And now we're talking about polynomial functions of higher degree, which we also touched on a little bit, but now we're really going to focus on their graphs. So exponents of polynomial functions must be whole numbers, all right? So that means I could have like x to the 0 power, x to the first power, x to the second power, x to the third power, but you can't have x to a negative power. You also can't have x to a fractional power. So I can't do like x to the 1/2 power. I can't do x to the negative third power. Those would not be polynomial functions. Also, the coefficients must be real numbers. So I can't take the square root of -5 and incorporate that into a polynomial function. That would not be a polynomial function then. We know that the square root of -5 is the same thing as I square root 5. So for that same reason, we can't have the letter I appear in a polynomial function. You'll notice that polynomial functions are continuous, so they start and they continue along a curved path, and there's no interruptions. All right. We also know that polynomial functions have smooth curves. There are no sharp turns in a polynomial function, so you'll always see kind of smooth transitions. We also want to take a look at some polynomials I wrote down at the bottom here. Some of these are polynomial functions, and some of them are not polynomial functions. So the first one, we know it is a polynomial function because all my coefficients are real numbers and all my exponents on my variables are positive, they're whole numbers. And for the second one, we know that it is not a polynomial function because x is inside the square root. And if x is inside the square root, that's the same as x to the 1/2 power. And I know I'm not allowed to have fractional exponents on my variable in a polynomial function. We know that the next one is going to be a polynomial function. My coefficient is allowed to be inside of a square root as long as it's a positive, right? So square root of a positive 5. That is okay, but you can't have square root of -5. All right, remember, exponents are different than coefficients, all right? And then the next one is obviously not going to be a polynomial function because if I have x in the denominator and I move that to the numerator, that would be x to the negative first power. Again, we're not allowed to have negative exponents on my variables when I'm talking about polynomial functions. Now, you can have negative exponents on numbers, that's fine. Like if I had 8 to the negative first power, well, that's okay, right? That's fine because 8 to the negative first power is just 1/8, and 1/8 is just a number. So you can have negative exponents on numbers, you just cannot have negative exponents on your variables. All right, coming up on the next one, this next one will be a polynomial function. Oops. Next one is a polynomial function. Notice it's just x to the first power there, so that's totally fine. I can have a number in the denominator, I just can't have a variable in the denominator. And the last one would not be a polynomial function. Again, you're not allowed to have negative exponents on your variables, all right? So x to the negative second power is not allowed. So here are some examples of polynomials and non-polynomial functions.